All right.
Good luck, guys.
Thank you. Ready, Mike?
Yep.
All right. Hello.
Hey, everyone.
All right. I think it's ready.
Okay. So welcome, everyone, to our AQ6380 Optical Spectrum Analyzer live stream. And my name is Michael Kwok. I'm the Business Development Manager here for the Optical Test Products.
I'm Danielle Awan. I'm an application engineer here at Noonan, Georgia.
Okay. And today we're just going to go over the quick summary of the agenda first. And if you have any questions, feel free to ask that towards the end of the session. We'll have a Q&A part. And let's go ahead and start.
Let's dive right in. All right, so our agenda for today is introducing just a brief description of Yokogawa's optical spectrum analyzers, what we have to offer. Then we'll sort of focus in on the AQ6380, just a quick maybe walk around, show off a calibration, show some demonstrations from some of our demos, show off some features of the AQ6380, such as the analysis feature, the sensitivity settings, maybe a comparison compared to an optical wavelength meter as well, and some more features such as our app features. All this will be shown on the viewer software, and then at the end we'll open it up for questions and answers.
So when we introduced this model right before the OFC, we actually earned a top score for the lab production equipment class in the Lightwave Innovation Review. So we got a very high score of 4.5 out of 5. Very proud of that. We actually received a very positive comment from one of the judges. He commented that it's a market-leading resolution and wavelength range, as well as enhanced automation for many measurement workflows. So we're very proud to have earned this high score and this trophy at the show.
Yeah, let me show that off real fast. So here we go. Let me change that view in the corner though. There we go. All right, so yeah, you can see the award right there.
Yep.
Then next.
So we want to start off just a quick introduction of our different OSAs. We make a whole family of different optical test solutions, but focusing on OSAs today, we've been making them since the 80s, since 1981, so over 40 years of experience. Currently we have 8 different OSA models, as you can see from our selection guide. We're the market leader in the grading OSA space. We offer globally known reliability, high resolution, dynamic range, and broad wavelength ranges as well. As you can see, we have some models that go up to 5.5 micron, all the way from visible to 5.5 micron. So we're going to talk about a few key features today. As I mentioned, one of the key things we want to show off is the 5 picometer resolution. We also have excellent 65 dB of dynamic range. We'll also talk about the 5 picometer of wavelength accuracy as well, comparing that to a wavelength meter. So we'll move on to the next screen to share the introduction of the front panel and hardware with you.
Okay, let me just change views right here. All right, sorry, I'm in the way. So right here we have the front panel of the AQ6380. Our biggest features, front panel wise, are the touchscreen now, so you can quickly just kind of change views, zoom in real easily, just like you would on a smartphone. You still have the buttons right here, but you can easily just go through, change your settings such as sensitivity, resolution, your start, stop, simple things like that. Pretty much everything the buttons used to do on the other models, such as the AQ6370, you can do from the touch screen now. And then you'll notice that we only have one port now, the optical input for the 6380. The calibration port is no longer here. Instead, calibration is done internally. So you would just set it up and it'll do everything internally instead of having to connect another fiber up right there. And of course, just for customers who may not be interested in the touchscreen, we do still have a familiar layout with the buttons. Easy to use, same sort of general design as we've had on many of our previous products, even back to the Ando, just a nice familiar button setting for our customers. All right, and then some key features as well, some others. So we do have 2 USB ports right here for customers to use. One can be used for a fiber inspection scope that we have right here. We also can do for the mouse as well, a USB mouse if you're more in tune to that. Of course, a keyboard as well. An external hard drive, those type of things if you need to use it. Ease of access with the 2 USB ports. And then going on to the rear panel, same ports as the AQ6380 series, as many of our others. We still include the GPIB. We have Ethernet ports. Commands are going to be the same. And then we also have the gas purging ports on the back. That is to kind of minimize that water vapor absorption. So all that noise you would get is pretty much purged, so you get a nice, cleaner signal. And then just to show off everything you can want to see here, I know it's pretty hard from that little camera to see exactly what is going on the screen. So we'll be also using the OSA viewer software to help us out here. So this trace you see, I'll be showing it off momentarily on the viewer software. And the viewer software is basically something that allows us to remote control the OSA from a computer, so you can transfer files. Any button presses you would do on the OSA can be done from a mouse on a computer, as long as it's connected with this viewer software. And of course, all of this is real time. You can also use it for offline analysis if you'd like. Just that sort of stuff to help out, you know, during analysis or post analysis. And then,
so as Danielle mentioned, there's an internal calibration light source that's now automated. So in the past, we've had a separate connector, and you had to connect a fiber to it, like the traditional 6370 series models. Now we were able to automate that because internally there's a single mode fiber. And what's happening inside is that there's an acetylene gas cell, and that gas cell has very, very precise, specific absorption lines. And what we're doing is using one of those notches or absorption points at 1530 nanometers to basically shift or align the internal calibration table. So it's a single point calibration. It can be done automatically. People can do that right before they start a measurement, or sometimes when you move the instrument, or there's a big temperature change or something like that, that's also recommended to make sure that the unit can perform this function. And
okay. And then I'm just going to pull up the viewer software. So we're not going to execute it right now because it does take quite a little bit of time to do. So we've already calibrated this unit, trust us, and you would just hit that optical alignment and hit execute, and it'll do that all internally. So let me get...
So next thing we want to talk about is really showcase that 5 picometer resolution capability. And we noticed that with an XFP module that's modulated, if we're using a lower resolution setting, like 20 picometer, which is what we offered for many years on the 6370 series OSAs, you can't really see those side lobes. So this is to showcase the fact that you really can see those side lobes clearly on both sides of the peak when you're using the 5 picometer resolution. So as you can see here, we did a sweep, and you can see those side lobes really clearly.
One second. So let me just pull it up. There we go.
You can really see those side lobes clearly. But if we change the setting back to 20 picometer and do another sweep, it looks a lot like our traditional model of 6370 series OSAs with the best 20 picometer resolution. So that would be the difference you would see between traditional 70 series OSAs versus a much higher resolution 5 picometer resolution 6380.
Yeah, so let's change it back to the high resolution.
Sure.
So I can just, wrong button. There we go. Oh, wait. Oh, there we go. Right. Yeah, so we can really see those sides pretty well now. Let us see. Okay.
So next thing we want to do is, we talked about the resolution, 5 picometer, but the wavelength accuracy is also now at 5 picometer, so that's also considerably better than our traditional OSAs. In fact, it's actually much closer to our optical wavelength meter specs, which is 1 picometer for the standard model and sub-picometer for the higher accuracy model. But what we've noticed is that customers have noticed that the spec has improved so much that they're reconsidering maybe if they only need 5 picometer resolution on their measurement, they may not need to buy a separate wavelength meter. They could just buy one OSA that will cover both the wavelength accuracy specs as well as the 5 picometer resolution. So kind of replacing 2 instruments with 1. So what we're going to do is demonstrate the peak wavelength difference between the 6380 signal that we just measured, which is showing at 1546.438, and this wavelength meter is showing 1546.435, so that's 0.03 picometers, within 3 picometer actually, so it's much better than the spec. Next thing we want to talk about is a new rapid sensitivity mode. So we are able to update and come up with a new algorithm to take advantage of the CW light to really speed up those measurements. As most of you know, when you increase the sensitivity of the OSA, the measurement will slow down. So as an example, we have a table showing the different settings and what the speed differences are between the different settings. So picking one that's highlighted here for, let's say, normal sensitivity. So that has a sensitivity spec of -65 dBm. So if you need that sensitivity value to make a measurement, traditionally you would use the normal mode and would take over 30 seconds to make that measurement. But with this rapid sensitivity mode, you can do that in 3.4 seconds, almost 10 times faster. So depending on settings, it could be up to 20 times faster, but this is just an example showing you that it's just considerably faster when you use the rapid sensitivity mode.
Okay. Should we stick on the XFP, or what would you like to?
Yeah, let's go ahead and take that.
Okay. Let me change it. Okay.
So the spec is for 100 nanometer span. So if I select the sensitivity mode to be rapid 3 and I do a sweep, and it's roughly 3 seconds.
Yeah.
But if you do it with a normal sensitivity setting, which is also minus 65 dBm, it's going to take a lot longer, so over 30 seconds. So
Yeah.
we're not going to go through the whole thing, but we're going to show you when it gets to roughly halfway to show you the peak. That's the difference it makes with a rapid sensitivity mode.
All right, there it is.
All right.
That took a little bit of time.
So next thing we want to talk about is the different analysis routines that's built in. So this is built in for your convenience. So there's a number of different analysis routines, just like our 70 series models and many models before this, for WDM analysis, DFB analysis, EDFA analysis and filters, and there's like over 10 or up to 13 analysis routines that's built in. So
Let's switch it then.
Okay.
Let's go to, sorry, I'm like messing up. Oh, let's go to, what is it?
the next slide should show
Then
SMSR. Yes.
changing that. Then let's do a sweep.
So analysis. We want
Or-
to change the span
Oh yeah.
back to maybe 5 or 2, just to show the 2 different peaks.
Oh, wait, let me change it to,
Go to analysis and press the analysis menu, and then
Change it
do
to
a sweep.
oops.
Auto. There's the trace.
Yep. So we can't really see any side modes on this trace. We just need to change the span a little bit so that we can get a reading, and then we can do the analysis.
There's the 5 picometer span.
Let me do that.
And
Okay.
there's the analysis, SMSR.
So
and
there
it's
we go.
done. So
Now we can
as
see
soon
it.
as it makes that sweep, it calculates all the values and shows that to you on the top screen. So there's multiple different modes you can set it to, but this is just an example showing how quickly you can do that.
Yeah, I mean, shows a pretty good description of the peaks, and of course, we also have, with that SMSR, you can do parameter settings to sort of automate as well. So we do that, and then executes. And so now we're showing like 2 peaks instead, just like an auto SMSR analysis. Pretty effective, shows those 2 next peaks pretty well.
Yeah, so you switch it from mode 1 to mode 4. Mode 4 shows you the peaks on both sides in case some people are interested in not just the next highest peak, but also both peaks on both sides of the center wavelength. Okay. So next thing to share is the app menu. So this is another new feature for the 6380 series, is a built-in application function that has some of the same analysis algorithms as the traditional one, but the unique part is the fact that you can use it, have a custom one that we tailor to any unique test that you may have that will work with you to tailor that. You can install it right on the instrument, and it'll be just a new icon.
And of course, we're releasing new apps slowly but surely. So the first one I'd like to talk about is the fiber inspection scope. So let me just get right back to that. And as as we can see, I have a fiber inspection scope right here, and then we also want to execute it. All right, there we go. So,
So the reason for doing this, of course, is to make sure that your fiber is clean, not contaminated. You want to check that and make sure that especially before you plug it into the OSA, because there is a fiber on the inside, you don't want to introduce any contamination or scratching of the internal single mode fiber that's inside the OSA.
okay, so yeah, we can see fiber is a little dirty, but mostly clean. I'll make sure to clean that better. But just as simple as going to that app menu and pressing it and quickly on the go, just checking to see fiber to make sure it's clean, optimal results. All right. Sounds good. And we can just exit that menu right there. This back. Right. And then
So go ahead and we want to show the WDM analysis as well using our FPLD.
let's just do an auto. Should be set already.
There we go. So this is a FPLD light source that we connected to just show multiple peaks to just demonstrate how that algorithm can easily and quickly identify those peaks and using a WDM analysis mode. So and just by pressing the button for WDM, it automatically identifies those peaks, gives you a table of the different channel spacing, power fluctuations or variations, and the OSNR, the signal to noise ratio between the peak and the noise level of this simulated signal to demonstrate the WDM analysis routine. So
yeah, we're already at question and answer.
Yep.
But
so for anyone that's interested in any more questions, feel free to let us know, and we'll address those as best we can based on what we can share with you. See the chat box for the questions.
Let's see if I can do that. Okay. So yeah, chat is empty right now.
Okay.
But I mean, we're here.
Yep.
It is a live stream, so I wonder. So we showed that.
We do have one question. Quality of the stream is great. Thank you.
It's great. Thank you very much. And of course, we can. It's question and answer, but we can show off these results as well. Oh, that's weird. Okay.
While we're waiting, I've been kind of blocking it, but this is actually our new 6070E model, which is the latest version of the standard resolution model. So this was just released last week. So we replaced the D model. So I don't want to steal the thunder, but I just want to mention that.
Yeah, I can show it off right here. So if you want to sort of point to it.
Yep. So it has actually been updated to have the same touchscreen capability, so you can do multi-touchscreen with your. I love doing this part. It's just being able to drag with two fingers and just make your screen wider or lower, and very similar operation as the 670, as the 80, which we've basically added to the new E series. So that'll be a topic for another
Another day.
introduction. We have another question. How can I measure signals from my free space devices? Okay, good question, common question, actually it's a common application. A lot of our customers use our OSAs to measure the optical components like TOCAN or TOSA or something like that, or maybe even a chip. So in order to do that, we do need to get the signal into a fiber. So we have come up with multiple solutions to do that. We published a guide that has a lot of details on what type of hardware to use to set up basically a jig to do that. And Danielle did a great video on this topic separately, but this is essentially the idea is that we have hardware that you can connect your free space light into, mount it like a TOCAN or something like that, and connect the fiber to the other side. The lens basically collimates the light, collects it into a fiber, and you connect that fiber to the OSA. So we just used this very recently for a customer to help them, I think, diagnose a LiDAR component that was in a free space beam. It's a good question. Thanks, Danielle. Does viewer software come with the OSA? The viewer software is available as an option. The nice thing is you have a 30-day trial. If you're not sure if you want to purchase it or want to make sure it works for you, you can download it from our website, try it out for 30 days, and then if you decide to like it, we can basically provide you the license key so you can continue using it on a permanent basis. It's actually really popular for people with maybe overseas manufacturing, something like that, where they want to be able to connect to the instrument when it's overseas. Sometimes they're in a different time zone and they're already sleeping, but the engineers could really diagnose the product or the issue remotely with that software, and they can do that while people are sleeping. So basically multitask that same instrument. And as Danielle mentioned, you can download the data and use that for analysis later as well. So, let's see. What are compatible fibers? For the 6380, it does have a single mode fiber input on the inside, and that's in order to get the highest resolution and performance, maximize that capability to give you that high resolution and wavelength accuracy. So you do want to use a single mode fiber with that. You do, on this traditional model, that's one of the differences. It has a free space input for that, where you can use multi-mode and different types of fibers. This is only for single mode fiber, and that's how we're able to do the automatic calibration, because it's fiberized. We can just connect it to a switch internally. For angle connectors, would I need an adapter? Yeah, you could just easily use a hybrid jumper with a PC on one end and an APC on the other end. That's what we would recommend. And most cases, we recommend having a sacrificial jumper anyways. So just have that jumper with APC on one end to connect to your APC light sources. Can I measure that for pump signal in 900 nanometer? Can I measure? Okay, I'm going to read this out loud. Sorry. Can I measure my ETFA pump signals in the 900 nanometer region? Yes, you can. With we actually have been asked that question because we do have a number of people working with 1 micron light sources and 900 nanometer light sources as well, and for ETFA pump. So in order to do that, you can request a special model that we haven't formally released yet, but we've built a number of these actually for the very kind of application. So it starts at 900 nanometers and goes to 1650. So there is a special version that you can order to take care of that 900 nanometer space, and also for LiDAR components as well. And you know, there's a lot of LiDAR signals in the 900 nanometer space.
I can't see from here, sorry.
What are the calibration options offered with the 6380 certificate of conformance? So, as far as the calibration certificates, we offer NIST traceable calibration. That's everything is tied to the NIST standards for that certificate. It's an option. The unit comes with a test certificate with the calibration data from the factory, but some customers need the NIST for US-based regulatory reasons, and we can provide it as an option. You request it when you order the unit.
Okay, just like a quick little null, I don't think we really showed off our setup, so I'd like to just, since we have some time, so just like a brief kind of description of what we have here. So for that XFP module, we have Yokogawa AQ1300 powering it, and it's just a simple cord. This right here that it's connected to is a module system called the AQ2211, and these are essentially switches. This is a DFB laser light source. This is another switch, the one we're actually using. And of course we have other modules that go with it, like attenuators. It's mostly that modular system, and it's easily hot swappable for ease of use. I can just take this out, plug it back in, and the system will detect it pretty easily. Just to show our setup, so essentially we're just kind of having all three of our sources going into this, and we're just switching out our main source from this input right here. And next we have, of course, the 80 that we were just showing off. And over here we have the optical wavelength meter that we were reading those power levels from. This one is the AQ6150, and then, of course, the AQ6370E, which is the successor to the AQ6370D that will be out very, very soon. So just like a kind of preview.
Yes.
And go ahead.
What is your favorite OSA model?
That's all you.
I would say the most impressive, there's two, I guess. This one, of course, is the high resolution. Very impressive. That's why we got the innovation high score. The other one is really impressive, is the one that goes to 5.5 micron. I think a lot of people, when they see this at the show, they are really impressed that we can do this with a grading-based OSA, which gives you many advantages in terms of the sensitivity, dynamic range, that cannot be offered with any other technology except for we're using an internal monochromator grading. So I would say those two. And we're always getting pushed to make longer and longer wavelength OSA, so the industry is keeping us busy, and we're happy to meet those requirements as we come across those.
If I had to say mine, it's just the 80. I like kind of the latest model. It's much easier to use the touchscreen than it is to use the capacitive buttons, but that just may be me. But newest is kind of nice to look at, essentially.
The fact that you can zoom in with your two fingers is so intuitive.
Yeah, just everything is just a click of a button, pretty much.
Yep.
That's the reason.
Yep.
And then we have another one.
Can I connect my keyboard or mouse onto the OSA? Yes. So you have the mouse, as Daniel pointed out, and you can click on this screen. This is what they call it, WYSIWYG. What you see is what you get. Kind of you see a parameter just like how we're touching it. So I don't know if you can see well enough, but there's boxes that show sensitivity, resolution. So basically, if you want to change that, instead of going to the button menu, which some people are great at because they've been using this OSA for many, many years, you can just touch that, or you can just use a mouse and put your cursor over that box. And what she just did was she used the right mouse key to pop up these buttons. So that's also really useful for the viewer software, because when you have the viewer software, you don't have access to the buttons. You click on the right mouse key and you're able to press those buttons as if you were standing in front of the machine, and you could be miles and miles away in a different country and drive the instrument remotely like that. You offer a production model of the 6380, making a faceless unit I can remote control. Excellent question. We've been asked that a number of times. We have a production version of our OSA. It's called AQ6380. It was on the list. I know it's really small in the beginning. There's a selection guide. So that's catered for high volume production. So it's designed to be much faster, but there's a trade-off with the performance, like the dynamic range or the resolution, but a lot of people don't need that in production. But specifically for the 80, we don't have a production model of this yet, and but the day may come where people are going to need this high resolution for high volume production, and we'll be happy to discuss those options in the new product development potentially. The other question was a faceless unit So all our units can be controlled remotely. We have been asked about having a faceless unit, meaning just a box with no display and buttons. It turns out the display was really a small part of the cost of the whole instrument, so it didn't really save much cost. The remote command's already there, and I know some people may be concerned about people touching the buttons, and that can be locked out too in production. So that is what we used to address that issue quite effectively over the past few years. Great questions, thank you. I like the one, the favorite one. Didn't expect that one.
Yeah, any questions in chat, we'll be happy to answer.
And by the way, as Danielle pointed out, we have a collection of these different instruments. This is our demo bench, we call it. We're in a demo room that we use for helping support customers for both pre and post-sale support. So if you have any questions or issues you want us to replicate, we can come up with the right type of equipment to closely replicate your situation and support you directly with some hardware as well remotely if we need to, or in person if that's what it takes. Sometimes we like to visit our customers to have face-to-face. Question is,
let me change.
What are you connecting the instrument to software? Is it USB? Actually, we're using the LAN port. The LAN port is much faster, and of course we had GPIB in the beginning, but when we came up with this viewer software to be able to connect it remotely, we found the LAN port was the fastest way to do it. The USB is there mostly for, as Danielle mentioned, the mouse, the probe, the keyboard, but for remote command is mostly the GPIB and the LAN port for highest speed, of course, and probably most cost effective. What are you connecting the instrument to software? Is it USB? I guess to answer the software question, it's the viewer software that we shared before. That's on our website. Yeah,
viewer software is LAN port or GPIB.
LAN only.
Yeah, not the USB. USB is mostly for those extra accessories or the externals or not connection.
Can you please give me an example of an application in which DUT would be useful? I'm trying to see what you mean. In an application in which the device under test would be useful. I can name a few device under test that I kind of mentioned earlier. The device under test could vary from your component level, like light sources, XFPs. So starting from the very, how to say, I like to use the word food chain. So something like the raw TOSA or the chip level of a light source, all the way up after it's being integrated into TOSA into a XFP module, an optical module, or all the way up to the system level. After you get these modules, you plug them into a line card and it becomes a part of a whole network equipment. So that's where you would use something like the WDM analysis to measure all your multiple channels. So you can use it for both single channel, very precise analysis of that signal, or move up to the chain of having multiple channels that are multiplexed together in a WDM network. So hopefully that helped address what your question was.
And then we do have another.
Do you guys do rental or loaner? We have multiple companies that, rental companies that have purchased and offer our 70 series OSA for rent. Not yet on the 80, just because the 70 has been around for so long, so it's much more popular. But for loaner, so we have worked with customers to provide loaner or demo units to just make sure that the measurements are what they believe will be effective to justify the purchase. So we do offer that. Contact your local
field application sales specialist as well
on a website.
And they'll of course help out to get one of these demo units out there to you.
As a matter of fact, Danielle just came back from a roadshow
with the 80.
With the 6380, and that work was very, I think, effective. And that's why we're doing this, to just really showcase the capability of being able to see the lobes like this in person versus just seeing it on a piece of paper, even online, but being able to just real-time try out the unit in the lab with their device under test, the customer's device under test.
I don't think any new ones. Okay. Not quite yet.
Sorry, I keep having to step up to the camera to read the screen. That's what happens when you get old and you need your eyesight.
I can't see the tiny font from here. But yeah, if we'll give it a few more minutes, and
thanks for all the great questions.
Yeah. Yeah, I like it's like you can really show off, like, this is what the 70D would currently show, so it's just like very, very smooth.
So it's misleading.
That's my best description for it, is very smooth. I'm curious to see if you do an SMSR analysis on it. Yeah, it's not quite picking it up too well. Let me switch back to that better resolution. Okay, and then if I run the analysis again, yeah, it's picking up two right there, the first two right there. So yeah, that resolution really, really helps.
Yeah, big difference.
That is.
Oh, you have the mode 4.
Yeah.
You can tell she likes to play with this stuff. That's awesome.
And then change it back to that. Good stuff.
Okay. Thank you. You guys have a good one. Thank you for attending.
Yeah, thank you very much.
I think it's about 45 minutes since we started. I think if feel free to ask any questions in the last minute or so. Other than that,
last call.
We'll be around. Go to our website. It should be links in the YouTube description. And feel free to contact us for any more questions or demonstration unit.
If you have a 6380, I can always help out with it as an application engineer. I am here to help out with any questions you have. If you have the unit, even loaner rentals, it's fine. I am here to help if you have a problem or an issue. Oh, we got one.
Yep. So the question is, I am considering purchasing a Thorlabs Redstone unit. Can you talk through the key features I need to consider? So excellent question. Basically asking between the key features between this unit and the Thorlabs Redstone unit. So incidentally, Thorlabs has their OSA line. They call it OSA, Optical Spectrum Analyzer, as well as we do. We actually don't feel, we actually have the same type of technology using a microsynth interferometer in our optical wavelength meter. So as I was showing earlier, it's great for showing the peak wavelength accuracy of the device, but it's not so great for when you need the dynamic range required in some of these cases, like showing the OSNR on the signals. For example, you have very low noise. So we really don't actually offer that capability with the interferometer-based wavelength meter. We advise people to use OSA because it's grating based and you can see that noise level and the dynamic range much better. So that's one of the key specs you should consider, and that's another reason why we do offer demo units, because we understand people want to see the differences and they really need to see what they may be missing before they make that decision by choosing those two models. And that's why we have loaner units, and we'll be happy to talk through your specific application if you contact us directly.
And there's another one.
How would I reach out to you, and where are your brochures? So our brochure's on the website. There should be a link in the YouTube description to reach us on our website. So tmi.yokogawa.com is, just remember the TMI in the beginning. Yokogawa.com, you can still reach us, but it's not as direct. But tmi.yokogawa.com, Test and Measurement Instruments, is the most direct way to reach our website, and you can go to contact us. Thanks for asking.
Oh, alrighty then.
Yeah.
So is this the last call?
Yeah, I think, well, we got a couple of at the last few minutes.
Yeah. Should we?
I think
we can wait a little bit.
Yeah.
1 or 2 minutes, and
Yep.
yeah, I mean, we're here for you.
Yep.
If you have a question, feel free to ask. No rush. You can print the screen, you can do all that. Yeah, so if I needed to like save a trace from the OSA, you just like hit that, or load a trace, or print the screen, or any of that type of stuff.
Okay, I think that's almost 50 minutes now.
Yeah.
Hitting
In
most
our
of our questions.
limit.
So thank you for joining, everyone, and we hope to see you again next time.
Bye bye.
Bye-bye. Thank you.